In this video, let us see angular projection. In projectile motion, there are two types: horizontal projection and oblique projection. In this case, body is thrown at an angle theta with the horizontal direction. Here initial velocity is u. Velocity along the horizontal direction is u cos theta. So now u is making theta with the horizontal direction. So velocity along the horizontal direction is u cos theta. Let it be ux. Then velocity along the vertical direction is u sin theta. Now equations of motion: v is equal to u plus at. First let us see horizontal motion. So we can write vx is equal to ux plus axt. Vx is equal to ux. Ux is u cos theta. Initial velocity in the horizontal direction is u cos theta. Then acceleration along the horizontal direction is 0. Acceleration due to gravity is acting in the along the downward direction. Then acceleration along the horizontal direction is 0. So ax is 0. So ux is u cos theta. That means velocity along the horizontal direction is not changing because there is no force in the horizontal direction. So vx is u cos theta. Initially it is u cos theta. When it is reaching the highest point also it is u cos theta. Only vertical velocity is going on changing. Now displacement along the horizontal direction, s is equal to u t plus half a t square. Since it is along the horizontal direction, instead of s you can write sx. Here ux, instead of u you can write ux, then ax. Then x is equal to, instead of sx you can write displacement along the horizontal direction. So instead of sx you can write x is equal to, instead of ux you can write u cos theta, then this t. Then since acceleration is 0, this term will become 0. From this you can get an expression for time. So time is equal to x divided by u cos theta. Then this is the expression for time. Next let us consider vertical motion. Then when it is vertical, instead of vx we can write vy is equal to uy plus ayt. Vy is equal to uy. Initial velocity in the vertical direction is u sin theta. Then acceleration due to gravity is in the downward direction. Motion is in the upward direction. So instead of ay you can write minus g, since acceleration is opposite to the direction of the motion. That is why minus, then gt. Vy is equal to u sin theta minus gt. Then displacement along the vertical direction, s is equal to ut plus half a t square. For vertical direction we can write sy, uy, ay. Then displacement along the vertical direction, so instead of sy we can write y is equal to uy, initial velocity in the vertical direction, that is u sin theta. Then for this time we can substitute x divided by u cos theta. Then instead of ay we can write minus g. Then instead of t we can substitute this t. You can write x by u. T you can write x by u cos theta. Since there is a square, you square all the terms. Then u will get cancelled. Sin theta by cos theta, tan theta. So y is equal to x tan theta minus half g x square by u square cos square theta. For this tan theta we can give the letter a. y is equal to ax, then x square. The remaining term you can give the letter b. You can express by b. So y is equal to ax plus b x square. So this is the equation of a parabola. So path followed by a projectile is known as trajectory. So this is a trajectory. So trajectory of a projectile is a parabola. Now let us derive an expression for maximum height reached in the case of angular projection. Equation of motion is v square is equal to u square plus 2as. Since vertical motion, we can write vy, uy, ay. Vy, when it is reaching the maximum height, velocity will become 0. So Vy will become 0 here. Vy will become 0. Uy, initial velocity in the vertical direction is u sine theta. Then ay, that is minus g, because acceleration is opposite to the direction of the motion. Motion is in the upward direction, acceleration due to gravity is in the downward direction. So instead of ay we can write minus g. So minus 2g. Instead of s we can write h max. Our aim is to find out maximum height, h max. Now you take this to the side. So 2g h max is equal to u sine theta. From this we can write h max, maximum height reached, is equal to u sine theta divided by 2g. So this is the expression for maximum height reached in angular projection. H max is equal to u sine theta divided by 2g. Now let us get a expression for the time taken by the body to reach the ground. That is known as time of flight. For that we can use this equation of motion. S is equal to ut plus half at square. Now when body is hitting the ground, vertical displacement is 0. Body was here. When it is hitting here, vertical displacement is 0. So here you can write vertical displacement sy, so uy, ay. When body is hitting the ground, vertical displacement is 0. So for this sy you can write 0. Uy, in vertical motion, we are considering vertical motion, so initial velocity in the vertical direction is u sine theta. Then this t, time of flight. So we can write time of flight tf. Then ay is minus g. So minus half. Instead of ay we can write minus g. Then time of flight. Time taken by the body to hit the ground is time of flight. So it's square. Now take this to the side. So half g tf square is equal to u sine theta tf. So here tf square, here tf. So one tf will get cancelled. So tf, from this we can write tf is equal to tf, time of flight tf is equal to, now this 2 can be taken there. So 2u sine theta divided by g. Time of flight is equal to 2u sine theta divided by g. So here you can see 2u sine theta by g. So time taken to reach the maximum point is u sine theta by g. Then from there to reach ground, again use sine theta by g. That is why it is 2u sine theta by g. From this is clear, time taken by the body to reach maximum height is equal to the time taken by the body to reach the ground from the maximum point. Time of flight is 2u sine theta by g. Now let us derive an equation for horizontal range. This is what is horizontal range. Horizontal range is equal to horizontal component of the velocity. So horizontal component of the velocity is u cos theta. You multiply by the time of flight. Velocity multiplied by time is the displacement. So time of flight, 2u sine theta divided by g. So range is equal to u square. Then as per trigonometry, 2 sine theta cos theta is sine 2 theta divided by g. Suppose the range is to be maximum, then we can find what is the angle needed. If the range for a given velocity, what should be the angle of projection to have maximum range? So the maximum value of sine theta is 1. Sine 2 theta is 1. Maximum value of sine 2 theta is 1. That is when 2 theta is 90 degree or pi by 2 radians. 2 theta should be pi by 2, or theta should be pi by 4. When theta is pi by 4, this will be 1. So maximum range is maximum, and it is equal to u square by g. For a given velocity, if range is to be maximum, angle of projection should be pi by 4. That means 45 degree.